Hello. In this video, I want to look at operations with radicals and look at the operations of addition and subtraction, and look at the operations of addition and subtraction, multiplication, and division. Let's suppose we want to take the square root of 35 and subtract 6 times the square root of 5. Now, in order to add or to subtract radicals, the radicands, the quantity under the root, has to be the same. But 35 is not the same as 5. I cannot simplify 35 to get a root 5, so there's nothing I can do to subtract these two expressions. Let's take this example. Suppose I have 1/3 times the square root of 27. I want to subtract 2 times root 3. Now, although the square root of 27 isn't the same as the square root of 3, I can simplify 27, which is 9 times 3. So that's root 9 times 3. But I can split a radical when I'm multiplying. So it's root 9 times root 3, and root 9 is 3. So I have 1/3 times 3 times root 3, and 1/3 times 3 is 1, so that's root 3 minus 2 root 3. So these radicals act like variables. It's the same as saying x minus 2x, but I'm saying root 3 minus 2 root 3. So I have 1 root 3, and I subtract 2 of them, I'm left with minus 1 of them. Minus 1 root 3, or simply negative root 3. Let's take a look at an example. This time, say where we have a cube root. And let's say I've got the cube root, well, say 1/3 times the cube root of 135 minus the cube root of -40. Alrighty. Well, 40 I know is 8 times 5. I know 8 is the cube of 3, or cube of 2 rather. So I've got right here negative the cube root of -8 times 5. And the cube root of -8 would be -2. So I've got -2 times the cube root of 5. This would give me 2 times the cube root of 5. Now, if I look at this at 5 and say, well, let me factor a 5 out of 135. Well, 5 into 135, that's going to go, what, twice? And that's going to be 27. 5 times 27, giving me 135. But 27, I know, is the cube of 3. So I've got 1/3 times the cube root of 5 times 3 to the 3rd. The cube root of 3 to the 3rd is 3, so I've got 1/3 times 3 times the cube root of 5 minus 2 times the cube root of 5. Hence, the cube root of 5 minus 2 times cube root of 5, leaving me with negative cube root of 5. Again, adding and subtracting, I must make certain the radicands are the same. Let's take a look at an example with a variable. Let's take a look at an example with a variable. Let's take this example here. Square root of 18 x to the 4th minus 3 times the square root of 8x to the 4th plus 2 times the square root of 50x to the 4th. All right. Well, 18 is 9 times 2. Root 9 is 3. Let me just write this out here. So that's 9 times 2. X to the 4th is x squared squared. So the square root of 9 would be 3. The square root of x squared squared would be x squared. I'm left with the square root of 2. X squared times the square root of 2. Now over here, 8, you know, is 4 times 2. And again, I've got my x squared squared. So this is going to be negative 3 times 2, 6, x squared, the square root of 2. Root 4 is 2, 2 times 3 is 6. 2 stays under the radical. The square root of x squared squared is x squared. And over here, well, 50, you know, is 25 times 2, and again, x squared squared. So I have positive. Now, root 25 is 5. 5 times 2 is 10. Root x squared squared is x squared times root 2. So notice two things. All of my radicals are the same, root 2. Notice also the variables are the same, x squareds. So I've got 3 minus 6 would be negative 3 plus 10, giving me positive 7x squared root 2 as my final answer. So here's an example of adding radicals with variables in the radicand. Once again, I've got to make certain the radicands must be the same in order to combine the radicals. And then, since I have variables here, they too must be the same to combine them. Alrighty, so for an example, let's just suppose a problem presented as this. Let's just suppose we had this example. 3x squared root 2 minus 6x squared root 2 plus 10 root 2. I could only combine these two terms, the x squared terms, giving me negative 3x squared root 2 plus 10 root 2. And that would be my final answer in that case. Let's look at a multiplication problem. And for the first example, let's just suppose I want to distribute. Let's take 5 root 10 times 3 root 2 minus root 5. 3 root 2 minus root 5. Well, I'll distribute as we would. So I have 5 times 3 is 15. Root 10 times root 2 is root 20. Minus 5 times 1 is 5. Root 10 times root 5 is root 50. Now, while these three radicands cannot be simplified, look what I now can do after I've distributed. Well, root 20, we know, is root 4 times 5. Root 4 I know is 2. I've got 15 times 2 times root 5, giving me 30 root 5, you see. 15 times 2 is 30, so 30 root 5. And 50, you know, is 25 times 2. Root 25 times 2. So I've got negative 5 times root 2. So negative 25 root 2. Now I've got a final answer, 30 minus 25 of 30 root 5 minus 25 root 2. Notice that this root 20 leaves a root 5. Root 50 leaves a root 2. And because these radicands are different, there's nothing more I can do. I cannot combine the radicals when the radicands are different. Our next example, let's consider foiling. Let's foil two binomials involving radicals. And the good news here is that the rules of foiling will be as they've always been, first, outer, inner, last. So let's take 5 root 6 plus 1 times 2 root 6 minus 3. And I'm going to FOIL. So first, 5 times 2, 10. 6 times 6, root 36. Outer, minus 15 root 6. Inner, positive 2 root 6. Last, negative 3. Now notice I've got some combining I can do because root 36 is 6. 10 times 6 is 60. Minus 15 plus 2 minus 13, root 6 minus 3. And finally, 60 minus 3, 57 minus 13, root 6. 57 minus 13, root 6. Let's take a second example of FOILing. Second example here. And this time, let's take this example. Let's take root 6 minus root 7 times root 6 plus root 7. Now you might recognize the form as difference of two squares. A minus b times a plus b. A minus b times a plus b, which you know gives us a squared minus b squared. Notice the middle terms will drop out. Now when I square a square root, I get the radicand. So root 6 times root 6 is root 36, which is 6. Outer, positive. Inner, negative. Drop out. Minus root 49 minus 7, result negative 1. So multiplying here, I've eliminated the radicals. Now this term is a special term. This term, root 6 plus root 7, is the conjugate of root 6 minus root 7. Similarly, root 6 minus root 7 is the conjugate of root 6 plus root 7. And this idea of conjugate will be very important when I want to divide radicals. Now, let's suppose I want to divide two radicals. Or you could say I would like to rationalize a denominator. So let's take this expression. Let's take 3 divided by 1 minus root 3.